So in our last class, we started linear programming and were able to discuss all relevant concepts in linear programming. We started with introduction to linear programming. We discussed the underlying assumptions of linear programming model. Then we talk about the methods of determining optimal production plan using graphical method. We talk about the concept of shadow price, including the method of determining shadow price. And we stop at increase the number of constraints by one. And I promised you that I'm going to give you the procedures involved whenever you want to determine shadow price using the dual method as well as increase the number of constraints by one. So within the next few minutes, we are going to talk about the procedures. Now, the first method of shadow price, the first method of determining shadow price is the dual method. All right, is the dual method. The dual method, I will advise at all time, whenever you want to calculate shadow price, always use the dual method. Why? Because one, it is faster. Then two, it's more straightforward relative to increase the number of constraints by one. So if you want to calculate dual method using, when you want to calculate shadow price using dual method, specifically there are about 3 or 4 procedures that you are supposed to carry out. The first step is to identify the equation that intercepts at the optimal level of activity. Okay? So the optimal level of activity is that level where the decision is made. All right. You have said that the company should produce so much quantity of product A, so much quantity of product B. All right. So that point, that level whereby the decision is made, that's the optimal level of activity. Therefore, so you are going to identify the two equations that intercepted at that level of activity. So that's the first step. Then the second step is to find the transpose of the original matrix. So the two equations you have identified in step one, you need to convert that original equation to dual problem. How do you do that? You convert, for you to get the dual problem, you find the transpose of the original matrix or of the original problem by changing row to column or column to row, whichever way you want to do it. It's still the same thing. All right. Then step three, you now solve the dual problem using simultaneous equation. The resultant figures will represent the shadow price. So that's what you need to do. All right. That's all you need to do. I will repeat again. To calculate shadow price using the dual method, you have 3 procedures. Step 1, identify the equation that intercepts at the optimal level of activity. Step 2, find the transpose of the original matrix by changing row to column or column to row. Then step 3, solve the dual problem using simultaneous equation, and the resultant figure from your simultaneous equation will represent the dual, will represent the shadow price. Okay, so that's basically what you need to do under dual method. The second method, which is increase the number of constraints by one. Again, you have about 5 procedures you are going to carry out in this one. The first step is to identify the equations that intercepts at the optimal level of activity. Then step 2, increase the number of the first constraint by 1, okay? You increase the number of the first constraint by 1. Then step 3, you solve the equations. You solve the equations using simultaneous equation, okay? You solve the equation simultaneously. That's step 3. Then step 4, you calculate new contribution margin, all right? You calculate new contribution margin using the result of the simultaneous equation. Okay, you calculate new contribution margin using the result of the simultaneous equation. That's step 5. All right. You then find calculate the shadow price. Calculate the shadow price of the first constraint. Okay. Calculate the shadow price of the first constraint. Then step 6, you repeat step 2 to 5, step 2 to 5, yeah. So you repeat the same way, in the second step, you have to increase the number of the first constraint by 1. So in that step 6, you are going to increase the number of the second constraint by 1. All right. Then you solve using simultaneous equation. Okay. After that, then you calculate the new contribution margin for the second constraint. Then you find the shadow price by deducting the new contribution margin with the existing contribution margin. All right. So that's basically what you need to do. We are going to test the two of them as we proceed. All right. So we have 2 illustrations to solve tonight, and then after the 2 illustrations, then if you still have time, I mean, likely introduce you to a cost volume profit analysis. But let's take it one by one. Let's have illustration first. Okay, let's have illustration. What's happening? Where are the rest of you? Please, have you called please let me send a message to the group. Tell them to join the class. The turnout is low. Oh, I want to believe they already know this, that's why. But in any case, lecture must move on. All right, so let's solve this illustration number 6. Okay, 30 marks. It's a compulsory question when it was tested. That was about 2-3 diets ago, thereabout. Okay. Yes. Who is helping us to read it? Who is helping us to read the question? Angela, you want to read? Okay, Femi. Angela, go ahead.
Okay, sir. Illustration 6. Oshimiri Nigeria Limited, a company based in Aba, produces 2 grades of industrial varnish. The selling price and associated unit variable costs for the grade A and grade B are shown below. The fixed overhead costs are 2.6 million naira per month. The company plans to maximize profits. The availability of resources for the following months is as follows. Required. Identify the objective function and the constraints of the model to be used in determining the optimum production plan for the following months. B. Determine the optimum production plan for the months and associated profit. C. Explain the concept and significance of dual prices and slack variables in the context of the model used by the company in this scenario. Calculate the dual prices for the constraints identified in this scenario. Suggest the ways in which the identified model can be used to overcome capacity constraints during the following months, and indicate the types of costs which may be incurred in overcoming each constraint.
Thank you very much, Angela. Yes, that is the question. In the A part of the requirements, you are to identify the objective function and the constraints of the model to be used in determining the optimum production plan for the following months. So examiner is asking you to formulate the linear programming model in the A requirement. So without wasting more time, I will stop sharing this and then move to the working note so that quickly we can solve the question. Okay. So the name of the company is Ashimiri Limited. So examiner is asking you to formulate the linear programming model. Anytime you want to, of course, to formulate a linear programming model, there are three procedures you are supposed to carry out. The first one is to state the objective function. Step two, you state all relevant constraints. Then step three, you state the non-negativity constraint. That's all. 5 marks within 2 minutes. You are done. Move to the next one. Okay? So I will then say A, formulation of linear programming model. All right. So the first thing you are going to do is to state the objective function. I will then go to the question. I need to go and identify from the question what objective does the company wants to achieve. All right. Is it to maximize contribution or to minimize cost? According to the question, and I told you when I was explaining the concept, if in the question you can see selling price and variable cost, you need nobody to tell you that the company wants to maximize contribution, all right? Because once you less variable cost from selling price, you are going to have contribution. It is also possible in the question, the examiner may give to you contribution directly, or if in the question, the examiner mention contribution and then or maybe they mention profit, it means that the company wants to maximize contribution. But if in the question, all what you can see are costs, there is no selling price, no contribution, no profit is mentioned in the question, it means that the company wants to minimize cost. But in this particular question, the paragraph after the first table, you are told that the fixed overhead costs are 2.6 million per month. The company plans to maximize contribution, maximize the profit. So the objective function is to maximize contribution. In this case, I would then say objective function maximization of contribution. If you like, you can call it profits. It's a maximization of contribution. Put it there. Therefore, we need to go and calculate the contribution margin for each product. So, without going too far, or let's see, this would be for, let me do the working here so that we are not switching pages. So let's calculate contribution margin here. Calculating contribution margin. Okay. We have grade A. We also have grade B. So selling price, to get contribution is selling price minus variable cost. Therefore, I will then go back to the question, what was the selling price of grade A? 2,100, then 1,500 for B. 2,100, 1,500. I will then less variable costs. Okay. To get the variable cost, I will go back to the question. I have material X. The material cost for grade A is 480, 240 for grade B. So material cost 480, 240. Next one. Again, I will go back to the question. We have labor cost. So there are two types of labor, skilled and also unskilled. So for the skilled labor, 720, then 288. 720, 288. All right. Next one. I have unskilled labor, 120, then 180. Unskilled labor. All right. Unskilled labor, 120, then 180. Then, after the unskilled labor, after labor, in the question, we're also given variable costs. Variable overhead to be 168 and then 336. Variable overhead. Variable overhead. Okay. 168, 336. 336. So these are all the costs given in the question. So let's find the difference to get the contribution margin. Give me the difference. What's the difference for grade A? Somebody is
612.
asking. Pardon?
312. 612.
612. Okay. Next one. Somebody.
456.
456. Good evening, sir. What page can I find the question? Joseph. Okay. Somebody has answered. All right. So 456. Yes. So that is that. That is that. Question. Is that not question number 6? Yeah. Question 6, page 48. Okay. So now that we have calculated the contribution, I can then come here to say 612 of A plus 456 of grade B. So with this, I have stated the objective function. Next one is to state all relevant constraints. According to the question, there are about 4 different constraints. So I'll just say subject to. The first constraint is material. Let me write that. Okay, material kilogram. According to the question, let's go back there. Yes. We are given material cost to be 480, then 240. We need to determine factor of production per unit. All right, we need to determine factor of production per unit. And to achieve this, I will then go ahead and calculate material kilogram. You don't use material cost. Rather, it has to be material kilogram. You don't use labor cost. It has to be labor hour. Therefore, I need to calculate material kilogram per unit. So material kilogram is calculated as material cost divided by material per unit. So for grade A, the material cost of grade A is 480. The material per unit of grade A, that would be, the material per unit is 240, okay? We are given 240. Therefore, this will give us 2 kilograms. Then for grade B is 240 divided by 240. This will give us 1 kilogram. All right. Then I also need to calculate labor hour. Okay, labor hour per unit. For grade A, to get labor hour is labor cost divided by labor rates. So for grade A, the labor cost for grade A, we have two types of labor, skilled. For skilled labor, for grade A, labor cost is 720 over the labor rate, according to the question for skilled, is 144 naira per hour. So divided by 144. So what do we have here? 720 divided by 144. 5 hours. Then for grade B, labor cost is 288 divided by 144, which is 2 hours.
Yes.
Then unskilled labor, for grade A, we have labor costs, unskilled labor cost is 120 naira. So here is 120 divided by labor rate for unskilled labor is 60 naira per hour. So 120 divided by 60 will give us 2 hours. Then for grade B, labor costs, unskilled labor
180.
costs, 180 divided by 60 will give us 3 hours. What else? We also have, according to the question, we also have matching hour as a constraint. And you are told in the question that variable cost is based on matching hour. Variable cost is based on matching hour. So, and variable cost per matching hour is 84 naira. So, matching hour. So, for grade A, the variable overhead
168.
is 168. 168 divided by 84 naira per hour, which is 2 hours. Then for grade B,
366. 336.
336 divided by 84.
4.
So this should give us 4 hours. Okay, so with this, we have determined the factor of production per unit. We have determined factor of production per unit. So we can then go ahead and complete the formulation of the linear programming model. All right. Examiner has already given us the capacity constraints. Okay, we have been given capacity constraint in the question to be 25,000 kilograms for material, to 48,000 hours for skilled labor, 39,000 hours for unskilled labor, and then 50,000 hours for machine hours. All right, so I can then go back here under material for grade A. Grade A material kilogram is 2, then 2 to 1. Okay, 2 to 1. So here will be 2 of A plus B. B is the same thing as 1. So you don't need to come and say 1B. So just put B, ignore the 1. B means the same thing as 1. Because we are maximizing contribution, then it will be less than equal to the total material kilogram available is 25,000. 25,000 kilogram. Then the second constraint is skilled labor. For the skilled labor per hour for material A, for grade A is 5 hours to 2, 5 to 2. Okay, so I will say 5A plus 2B less than equal to the total skilled labor hours available in the question is 48,000 hours. So 48,000 hours. Then unskilled labor. Based on our working, the unskilled labor hour per unit is 2 to 3. 2 to 3, so 2A plus 3B less than equal to 39,000 hours. Then the last one is matching hour. Or simply put, matching. All right. Under the matching, we have calculated it to be 2 to 4. 2 to 4 hours. So 2A plus 4B less than equal to 50,000 hours. So with this, we have stated all relevant constraints. Finally, step 3 for the formulation, you need to state the non-negativity constraint. Non-negativity constraint, which state that negative output is not permitted, all right, and that the least that can be produced is 0. Therefore, we have two variables, A and B. Okay, A and B must be greater than or equal to 0. So with this, we have stated we have formulated the linear programming model. You can see that the relationship between the objective function and the constraints or other factor of production are expressed in linear fashion. All these expressions are what we call linearity. Okay. All right then. So 5 marks, you pocket this. You are looking for 95. Let's go there. The next one in the B requirement is to determine the optimum production plan. for the month and the associated profits. This is too small for 5 marks. It should be more than 5 marks. But again, this A requirements and the B requirements, ordinarily they're supposed to be together. All right then. So I've done work in here. Let me start in the next one. So number B, we want to calculate, you want to determine optimal production plan. So determining optimum production plan. The optimal production plan is the one that will maximize the organization's contribution. Okay, so to do this, remember, I gave you about 7 or 8 procedures you are supposed to carry out anytime you want to determine optimum production plan. Out of this, examiner has already given you, you have already done in A part, which is to formulate the linear programming model. So I don't need to waste my time in this. So the next thing I need to do now, all right, step 1 I'm going to do here, because I've already formulated the linear programming model, is to bring out the equation and solve using the elimination method. Okay, step 1. So you can say on the day of your exam, there is no need for you to say bring out the equation and solve. Just go ahead, continue calculating. So you don't need to waste time. But for the purpose of this class, I will just say bring out the equations. Okay, what are the equations? I will then go to the formulation of linear programming model. All right. Equation 1 is 2a plus b equal to 25,000 kilograms. All right. Equation 1 is 2a plus b equal to 25,000. That's equation 1. Equation 2. Equation 2 is 5a plus 2b equal to 48,000. Let me rewrite this. 5a plus 2b equal to 48,000. Equation 3 is 2a plus 3b. 2a plus 3b equal to 39,000. Equation 4 is 2a plus 4b equal to 50,000. So these are the 4 equations. At this point, you need to determine value for each of the variable. You need to calculate value for A and B for each of the equations using the elimination method. So I will then bring out the first one. The first one is 2a plus b equal to 25,000. All right. Using elimination method, I would then say let A equal to 0. If A is equal to 0, then B will be equal to 25,000. Since I've gotten value for A, I will then say, still on the same equation, let B equal to 0. If B is equal to 0, then 2A is equal to 25,000. Therefore, A will be equal to 25,000 divided by 2. Divided by 2. Therefore, A will be equal to 12,500. A will be equal to 12,500. Priska, Joseph, mute. Now, I'm done with equation 1. I will then move to equation 2. Under equation 2, we have 5a plus 2b. 5a plus 2b equal to 48,000. This is equation 2. Again, let a equal to 0. If a is equal to 0, then 2b will be equal to 48,000. Therefore, b is equal to 48,000 divided by 2. So b equal to 24,000. Again, let's b equal to 0. If b is equal to 0, then 5a will be equal to 48,000. Therefore, a will be equal to 48,000 divided by 5. Therefore, a is equal to, that should be 9,000.
9,600.
9,600, okay? I'm done with equation 2. I will move to equation 3. Under equation 3, we have 2a plus 3b. 2a plus 3b. Let me close this. 2a plus 3b equal to 38,000. All right, then let a equal to 0. If a is equal to 0, then 3b will then be equal to 38,000. Therefore, b will be equal to 38,000 divided by 3. Yes, Angela, talk to me.
So I
Sorry,
think it's
13.
39,000.
Yeah, 39,000. Thank you. All right. So 39,000 divided by 3 will give us 13,000. Let b equal to 0. If b is equal to 0, then 2a will be equal to 38,000. Therefore, a equal to 38,000 divided by 2. Then a will be equal to 19,000, I
19.
think, yeah, 19,000. Then the last one, the last equation is 2a plus 4b. 2a plus 4b equal to 50,000 hour. So let's a equal to 0. Then 4b equal to 50,000. b equal to 50,000 divided by 4. So b equal to 1, 2,
12,500.
12,500. All right. On the other side, let b equal to 0. Then 2a will be equal to 50,000. A equal to 50,000 divided by 2. So A equal to 25,000. Now, we are done. So the next thing we need to do is to construct a pivot table. We need to construct a pivot table. All right, step 2, construct, or simply put, pivot table. So to construct the pivot table, just input all the numbers, all the numbers of A and B in the step one in those eliminations. So put it in the pivot table. That's all. All right. We have A. We also have B. Here will be for the equations. Now, the first equation is 2A plus B. 2A plus B equal to 25,000 kilograms. The second equation is 5A plus 2B equal to 48,000. 5A plus 2B equal to 48,000. The third equation is 2A plus 3B. This is 39,000. I've not corrected it. Okay.
The value of V for that odd equation.
Let me confirm it. Is it 39 or 38? $39 or 30? Oh, okay, that's error from my side. I have not corrected the adjustment I made the other time. Okay. This is supposed to be 39. Here too is 39. So 39,000 divided by 2 will give us 19,500. Okay, I think that's okay now. All right then. Now, for the third equation, 2A plus 3B. 2A plus 3B equal to 39,000. And the last equation is 5A. This is equation 4. 2A plus 4B. 2A plus 4B equal to 50,000. All right. Okay. Now, from our equation, the first equation, when A is equal to 0, when A is equal to 0, we calculated B to be 25,000. 25,000. When B is 0, A is 12,500. In the second equation, when A is 0, B is 24,000. Okay. When A is 0, B is 24,000. And when B is 0, A is 9,600. Equation 3. When A is 0, B is 13,000. A is 0, B 13,000. B is 0, A is 19,500. The last equation, A is 0, B is 12,500. B is 0, A is 25,000. So this is our pivot table. Now, after the pivot table, we need to construct a graph. Is the result you have in the pivot table you are going to use to draw your graph. Let me see, can I use this small space to construct my graph? Okay, this should be sufficient. Let me see, 1, 2, 3, 4, 5. Okay, let me manage this. Let me redraw it. Okay. So starting from 0, then we need to scale. We need to scale our graph. All right. So the highest figures for A is 25,000. The lowest figure for A is 9,600. So let's say this is A axis. Here is B. All right. So for A, in the first equation, before that, let's scale our graph. Highest is 25,000, lowest is 9,006. So let's use 5,000 each. So let's say this is 5. Let me start, should I start from here? Oh, okay. This is 5,000. Here is 10,000. Or I should even double it. Double the cell. Let's manage it. Here is 15,000. Here is 20,000. And here is 25,000. Okay. Do the same thing. For B, highest is 25, lowest is 12.5. So I can say this is 5,000. Here is 10,000. Here is 15,000. Let me write this. So 5,000, 10,000, 15,000, 20,000, then 25,000. All right. So we are going to plot A against B. So in the first equation, 12,500 for A. So I need to, from my graph, I need to identify where I can indicate 12,500. So 12,500 would be between 10,000 and 15,000. So here will be 12,500. Okay. Let me see. I can use a different color for that. Okay. Oh, it's not changing. Anyway, so again for B, 25,000. I will go to B where I can identify 25,000. Here is 25,000. So I need to plot 12,500. I will plot 12,500 against 25,000. So this will come like this. So that's that. Write out the equation. This is equation 2A plus B equal to 25,000. All right. Then move to the next one. A is 9,600. 9,600 is close to 10,000. Let's say 9,600 is here. 9,600.
Yes.
All right. Okay. Then B. B is 24,000. 24,000 is close to 25,000. Let me even redraw this one so that it will align. Okay, better. Now, 24,000 is close to 25,000. So let's say 24,000 is here. So here is 24,000. All right. Therefore, I will plot 9,600 against 24,000. Okay. Let me push it a little bit. Okay, we manage it. Then you write out the equation. This is equation 5A plus 2B. 5A plus 2B equal to 48,000. The next one, equation 3, 19,500 for A. 19,500 is close to 20,000. So let's say 19,500 is somewhere here. 19,500. Then for B, B is 13,000. 13,000 is almost in between 10,000 and 15,000. So let's say 13,000 is somewhere here. All right. 13,000. Let me push it a little bit to the front. 13,000. So you are going to plot 19,500 against 13,000. Wow. Let me see. I'm not using ruler. Let's see how it will work out. Okay, better. So you then write out the equation. All right, write it out. This is equation 2A plus 3B. 2A plus 3B equal to 39,000. The last one, okay, the last one is 2A plus 4B. So A is 25,000. Here is 25,000 for A. Then B is 12,500. 12,500 will be somewhere behind this 13,000. Okay, so 12,500 will be here. Okay, so if that is the case, we need to join the two together. All right, let's see. I'm struggling. You see what I'm going through here. Okay, then. All right. We manage it. Let's redraw this 13 something. It remains small. It remains small. Oh. Okay, let me do 3. 13, 19,500 to 13. I've mistakenly delayed that. 19,500 to 13. Better. Then the last one, 25,000 to 12,500. 25,000 to 12,500. All right then. So, all right, we manage this as it is. So at this point, we need to determine the point of intersection between, let's write out the equation. Let me do this. This is equation 2a plus 4b equal to 50,000. Ordinarily, let's see. Let me go back to my, if I can still change this one to, I don't know why it's not changing to red. Okay, I think we got to it. So let me see if I can change all this arrow. The first one, I think, is this one. This one. The first one is, sorry. The first one is 12,500 to 25,000. Okay, this is it here. I want it to look different so that then this one is this. I will remove this one. Then the last one is this one here. Just here. Okay. Then all these ones, the one we are picking. I want it to look different so that you know. All right. So let me return it to, or before then. Now, at this point, you need to find the point of intersection between A and B. Now, when you are maximizing contribution, let me return to blue color. When you are maximizing contribution, your feasible region will be internal towards 0. Okay? Now, in this question, we are maximizing contribution. So you need to find the point of intersection internal towards 0. So in this case, A and B intercepted at this point. Since we are using A and B, we have grade A and B. So let's use another letter. You can say this is point X. Then A and B also intercepted at this point. Okay, A and B intercepted at this point. Let's call that point as Y. There is another point of intersection here. Okay, let me push it up a little bit. Oof.
Yes.
Let me undo. Okay. Let me see. Where's my undo? It's nobody else. Okay. Better. Okay. I can go back. So initially I wanted to just oh, there's one more. One more is missing. It's not yet. Yes, one more line is missing there. Better. It's complete now. Okay. What's wrong with you now? Let's say, let me just leave it like that. Because of time. Okay, so X, Y, let's say this is point Z. All right. Then A and B also intercepted at this 12,500. Yeah. So let's call that one. We have X, Y, Z. Then we can call it another letter. Let's say M at point M or T, whichever one you want to put it. X, Y, Z, M. Okay. This is 1 point, another point, another point. So all these areas are what we call the feasible region. These are the feasible region. Because you are maximizing contribution, to get the feasible region, you are going to identify the point of intersection internally towards zero. Okay? So like I said, let me use red. So A and B intercepted at this point where you have 9,600. Also, A and B intercepted at this point here. A and B intercepted at this point here. And then lastly, A and B intercepted at this point. The first point of intersection is X, followed by Y. Let me remove this. Let me rewrite this Y to make it bolder. Okay, let me change everything to red color then. X, Y, then Z, M. Let me remove this. Okay, so those are the 4 points of intersection. So at this point, you need to get value, you need to determine value for X, Y, Z, and M. So you need to get value for A and B at each point of intersection. So I can then say, A and B at point, we have point X, Y, Z, M. So we need to get value for A and B at each point. Because of time, let's move on. So for point X, at point X, where you have the 9,600, the value of A is 9,600. So here will be 9,600. At point B, at that point X, value of B is 0. So you trace it down. 9,600 and trace it down where you have B. So that's 0. Then at point Y and Z, you cannot get the value of A and B if you are not using a graph sheet. Because if you trace it to the left, you can't have the right answer. If you trace it downwardly, you cannot have the correct answer, except if you are using the graph sheet. Therefore, you are supposed to use simultaneous equation to get the value of A and B at points Y and Z. So we're coming back to that. But the last one, which is point M, A at point M is equal to 0. B at point M is equal to 12,500. So here is 0, here is 12,500. So we need to go and get value for X and Y, value for A and B at points Y and Z. So I can then say to get value, to get the value of A and B at points Y and Z, the most important thing to do the most important thing to do is to, one, identify the equations that intercept at each point then two, solve the equations simultaneously. Okay, so to get value for Y, to get value of A and B at point Y, first thing first, we need to go to point Y. This is point Y here. What are the equations that intercepted at that point Y? I can see this equation of 9,600 and 24,000. That's the first equation that intercepted at that point Y. So 9,600 to 24,000. On our pivot table, where do you have? So that's equation number 2. Equation number 2 is the 9,600 and 24. So which is equation 5A plus 2B. 5A plus 2B. So I would then say at point Y, 5A plus 2B equal to 48,000. The next one, we have only identified, there are two equations that intercepted at this point Y. The second equation is this one of 19.5 that went down, 19.5 to 13,000. That's the second equation, 19.5 to 19.5 to 13,000. Okay, which one is 19.5? Yeah, that's equation 3. Equation 3 also intercepted that. So that's equation 2A plus 3B equal to 39,000. 2A plus 3B equal to 39,000. So let's identify all the equations at once. Or let's solve this one first. So the second, we have identified at point Y, we have identified the two equations. So let's solve using simultaneous equation. So I would then say, to get the simultaneous equation, you are going to multiply the first equation by the first figure in the second equation. So 2 multiplied by 5A plus 2B equal to 48,000. Then you multiply the second equation with the first figure in the first equation. 5 multiplied by 2A plus 3B equal to 39,000. All right, so here will be 10A plus 2 multiplied by 2, 4B. 2 multiplied by 48, 96,000. Then 10A plus 5 multiplied by 3, 15B. 5 multiplied by 39,000. What do we have there? 39,000 multiplied by 5. That's 195,000. So this will cancel this. 15B minus 4B equal to 195,000 minus 96,000. Therefore, 11B equal to 195 minus 96 minus 96,000. That's 99,000. Therefore, B equal to 99,000 divided by 11. So 99,000 divided by 11, that's 9,000. B equal to 9,000. All right. So you then substitute. I will say substitute for B in any of the equation above. Let's say in equation 1. All right. So meaning that anywhere you see B, you put 9,000. So in the first equation, which is 5A plus 2B, so 5A plus 2 into 9,000 equal to 48,000. All right. So 5A will be equal to 48,000 minus 18,000. Therefore, 5A will be equal to 30,000. All right, 5A will be equal to 30,000. Therefore, A equal to 30,000 divided by 5. So A equal to 6,000. So A is 6,000, B is 9,000. So I can then come here. A is 6,000, B is 9,000. So if you are using a graph sheet, at this point Y, if we trace the point Y, if we trace it to the left, when you are using a graph sheet, you are going to have 6,000 there. Also, at this point Y, if we trace it downwardly, you are going to have 9,000. All right? So that is that. Then the next one is point Z. Point Z. We want to get value for point Z. So at point Z, okay, what are the two equations that are intercepted at point Z? Let's go and identify it. At point Z, so we have this equation of 12,500 that went up. There are two equations here. We are looking at this point Z. So we have the equation that went up, this 25,000 and 12,500. That's the last equation here. Let me remove this. So that's the last equation here. Then there is another equation, this equation of 13,000, 19,500 and 13,000. Okay, 19,500 and 13,000. I think that's equation 19,500 and 13. That's equation number 3, 2A plus 3B. All right, so the last two equations intercepted at point Z. All right, the last two equations intercepted at point Z. So, which is 2A plus 3B equal to 39,000. So, 2A plus 3B equal to 39,000. And the last one is 2A plus 4B equal to 50,000. Equation 1, equation 2. So these are the two equations that intercepted at point Z, So if that is the case, then we now solve using simultaneous equation. Again, you can see 2 already equal to 2. So just cut this one into 2. I would then say 4B. There's no need for me to multiply 2 multiplied by 2 or 2 so it's a waste of time since I can see that 2 already cut 2. So just say 4B minus 3B. Sorry, 4B minus 3B equal to 50,000 minus 39,000. So B equal to 11,000. All right, then substitute. For B in equation 1. All right, the first equation is 2A plus 3 into 11,000. Anywhere you see B, put 11,000 equal to 39,000. Therefore, 2A will be equal to 39,000 minus 33,000. Okay? Therefore, A will be equal to 6,000 divided by 2. A will be equal to 3,000. So A is 3,000, B is 11,000. 3,000, 11,000. Again, from your graph, at that point Z, if you trace it to the left, you are going to get 3,000 there. If you trace it downwardly, you are going to get 11,000. All right? So that's that. That is if you are using a graph sheet. If you are not using a graph sheet, there is no way you can, if you trace it to the left or downwardly, you can't get the correct answer. If you get it correctly, that means you are just lucky. All right? So the only way you can get it correctly is to use simultaneous equation the same way we have done so far. All right? So that is that. Now that we have gotten value, the next step is to construct the solution table. All right, determine the solution table. So that will be step 3 or step 4. Graph is step 2. Graph is step 3. Then A will be step 4. Solution table. So this solution table is more like the allocation table under the key limiting factor. Okay, so it states the objective function. So the objective is 612 naira of A plus 456 naira for B. So meaning that anywhere you see A, you are going to put the quantity you have already put in your graph. You are going to put the quantity, you replace A and B with the quantity. So I will then say at point X, Y, Z, and then M. Our total contribution will be here. Okay. Here will be total. So let's go back. Let's go back to those figures we have identified. At point X, A is 9,600, B is 0. Therefore, I would then say 612 multiplied by 9,600 plus 456 multiplied by 0. Give me the figure. At point Y, 6,000, then 9,000. 6,000, 9,000. So here will be 612 multiplied by 6,000 plus 456 multiplied by 9,000. 612 multiplied by at point Z. At point Z, 3,000, 11,000. Here is 3,000 plus 456 multiplied by 11,000. The last one, 612 multiplied by 0 plus 456 multiplied by 12,500. 12,500. So give me the total contribution, please, for each one. That is
X is 5875,200.
total answer. So you open a bracket. In your calculator, open a bracket. 612 multiplied by 96. Close the bracket. Plus, open another bracket. 456 multiplied by 0. Close the bracket. Equal. That's 5875,200. 5875,200. 5,875,200 naira. Then the second one, you open a bracket. 612 multiplied by 6,000. Close the bracket. Plus, open another bracket. 456 multiplied by 9,000. Close the bracket. Then equal 776 7,776,000. Okay. The third one, open a bracket, 612 multiplied by 3,000. Close the bracket, plus open another bracket, 456 multiplied by 11,000. Close the brackets, equal 6,852,000. Let me write this 7 here. Okay. And the last one, of course, anything multiplied by 0 will be equal to 0. Let me just do the other one. 456 multiplied by 12,500 equal 5,700,000. 5,700,000. So this total is just like optimal production mix that you normally do under the key limiting factor, that last column. So at this point, you need to select. Since we are maximizing contribution, you will select the highest total contribution. When you look at our calculation, the highest is at point Y. Highest is 97,776,000. That is at point Y. Okay? So that is that. Okay. What that simply means is that to now get the optimal production plan, step 5, is it 5 or 6? 5, okay? The optimal production plan. So it means that the company should produce, based on our decision, the company should produce 6,000 units of grade A and then 9,000 units of grade B in order to maximize contribution of 7,776,000. So I can just come here, okay? Units, then grade. Grade A, grade B. For grade A, we are producing 6,000 units. Grade B, we are producing 9,000 units. So if you like, you can say, what's the name of the company again? Oshimiri. You can say Oshimiri Limited should produce 6,000 units of grade A and, grade A and 9,000 units of grade B to maximize contribution, to maximize total contribution, total monthly contribution of 7,776,000. Let me write this one. 776,000. Okay, that's it. This is not all. Examiner also tell you to you can imagine 5 marks since examiner is not fair in this requirements. This should be more than 5 marks. All right.
We'll jump
So,
Sir, is it that
pardon?
there's no shorter way to calculate this?
Of
Must we
course,
follow this long process?
there is another way you can do it, but I like to follow procedures. When you look at the way ICAN, when you go to the ICAN study pack, I think the way it is there is a way it was solved other than this one. But I don't like following a shortcut. But in any case, let's move on. That's one of the issues with linear programming. It takes time, even if we follow the other one. All right, so let's move on. Examiner is asking you to determine maximum profits. So I can then say monthly profits. Monthly profits. All right. So to get the profits, profit is contribution less fixed overhead. So I would then say contribution figures are, okay, let me just put it. So monthly contribution is 7,776,000. Then fixed overhead. You have to be very careful so that you don't give what belongs to Peter to Paul. This overhead, let's go back to the question. Is it a monthly overhead or a yearly overhead? So according to the question, you are told that fixed overhead costs are 2.6 million naira per month. At times, examiner may give it to you per year, and the contribution may be per week or per month. So you have to be very careful that the two of them that they match. This is month versus month. So, but if it is month versus year, so you need to convert one. For example, if this fixed overhead is per year, so you need to convert it to per month so that you are using apple for apple. So here will be 2,600,000. So find the difference. That will give us 5,176,000. So that's the monthly profits. That's monthly profits. So we are done with that. We are done with that. So the next requirement, which is number C, is to explain the concept and significance of dual prices and slack variables in the context of the model used by the company in this scenario. So, examiner is asking you to explain the concept of shadow price. When you say dual price simply means shadow price. So, examiner wants you to explain the concept of shadow price. Just explain what is shadow price, what are the importance of shadow price. So that's what you are going to state there. All right. So let me see if I can share golden book with you so that let me see. Okay. Yes. So like I said, to answer the requirement number C, just explain what is shadow price. Then you then begin to mention the significance or importance of shadow price. So like we have done in the past, shadow price represents the extra contribution derivable from the additional units of limited scarce resources that have been fully utilized at the optimal level of activity. It is the amount a company is willing and ready to pay for the use of an additional unit of a constraint. All right. So we are saying that, okay, our decision here is that the highest level of activity is that point Y. Okay, the highest level of activity is point 4. So it is that point where you are going to see binding constraint. So at that point Y is where you are going to get the extra contribution derivable from the additional unit of that constraint. So that's what we are trying to say here as far as the dual price is concerned. Then what are the significance of shadow price? The dual price, the following are some of the uses or significance of dual prices. One, it is used to determine the extra profit derivable or achievable from the additional unit of a constraint. Two, it can be used to determine the maximum amount that a company is willing and ready to pay for its scarce resources. Then three, it is suitable for determining shadow price. Yes, we can use for determining transfer price. We can use dual price to determine shadow price. Sorry, to determine transfer price. Okay. Then three, number four, it can be used to determine the sensitivity margin of a scarce resource. All right, it can be used to determine the sensitivity margin of a scarce resource. So these are the significance of shadow price or dual price. So yes, let me stop sharing. Somebody is sending message. Okay, still the old message. No. Okay, Kemi. Thank you, Kemi. Yeah, let me stop sharing this and then move to the main, the second, the number D requirement of the question. The D requirement of the question, examiner is asking you to calculate the dual price for the constraint identified in this scenario. 10 marks, you can imagine. I can tell you this requirement will not take us yes, maybe 10 minutes because I'll be explaining. It can't take us more than 10 minutes and the examiner has given you 10 marks. That's a bonus. In any case, for the D part of the requirement, so you have to determine shadow price. So don't forget, like I said, shadow price is the same thing as dual price. Let me put it this way. Determining dual shadow prices. So now you can either use dual method or you use increase the number of constraints by 1. So I've already explained to you last week. Please, at all time, always use the dual method to calculate your shadow price. It is faster and more straightforward. So to calculate the dual price, to calculate the shadow price using the dual method, there are 3 stages. There are 3 procedures you are supposed to carry out. Because of time, step 1, okay, you identify the equation that intercepts at the optimal level of activity. So the optimal level of activity is at point Y. So I don't need to tell you on the day of your exam, there is no need for you to say, identify the equation that intercept at optimal level of, it's a waste of time, all right? So just bring it out yourself. Bring out the equations at the optimal level, okay? Equations at optimal level of activities. So you then go back to where you have made a decision. Optimal level of activity is this point Y. That's where you made the decision. At that level, at point Y, what are the two equations that intercept at point Y? We have done it before. Okay, this is the point. This is point Y here. The two equation is 5A plus 2B equal to 48,000. So those are the two equations. So I will come here. Equation at optimal level of activity, that is point Y. Okay. So at point Y, we have 5A plus 2B equal to 48,000. Then the second equation at that point Y is 2A plus 3B equal to 39,000. 2A plus 3B equal to 39,000. That's equation 2. So these are the two equations that intercepted at the optimal level of activity. So with this, I can then find to now get the dual problem. I need to first of all bring out the original matrix. All right. The original matrix will then be 5A. Let me put it this way. Original problem will be equal to 5A plus 2B equal to 48,000. Then 2A plus 3B equal to 39,000. The contribution of A is 612 plus contribution of B, which is 456. If you like, you can indicate the error sign. So this is the original problem. So now get the dual problem. You know, the first one says you should identify the two equations that intercept at the optimal level of activity. Step 2 says you should find the dual, or you should find the transpose of the original problem. We have identified the original problem. The next we want to do now is to now find the dual problem. Dual problem. Epele. It is well.
School will not allow you to.
To find the dual problem, you need to change row to column or row to column. The first row is 5A plus 2B equal to 48,000. Change it to columns. That means you are finding a transpose. So here will be 5. The first row is 5 and 2. So 5, 2, then 48,000. The second row is 2B, 2, 3, 39,000. So change it to column. So here will be 2, 3. Let me rewrite that. 2, 3, 39,000. And the third row is 612. And then 456. 612, 456. Now, when you are finding the dual problem, everything about the original matrix will change. All right? You are changing row. We change row to column, or you change column to row, whichever one you want to do it, it's still the same thing. Now, in the original problem, we are maximizing contribution. As you are changing to dual problem, it will become minimization of cost. In the original problem, the constraint is 48,000 and 39,000. Now it has turned to cost. It's no more a constraint. It has turned to cost, 48,000 and 39,000. The contribution you have before has now turned to a constraint of 612 and 516. Now, in the original problem, the letters we have there are A and B. So as you are moving to dual, you also need to change the letter. We can use X and Y. Okay, so let's say this is X, Y, X plus 3Y, X plus Y. So equal to. So this is how to find the dual problem. So the step says that after you have found the dual problem, you need to solve using simultaneous equation. So solve the dual using simultaneous equation. Okay. So if that is the case, I would then say 5x, here is 5x plus 2y equal to 612. 2x plus 3y equal to 456. This is equation 1. This is equation 2. All right. So I would then say 2 multiplied by 5x plus 2y equal to 612. Then 5 multiplied by 2x plus 3y equal to 456. Let me write this 5. Therefore, 2 multiplied by 5 will give us 10x plus 4y equal to 2 multiplied by 612. You give us 1,000. What is that? Here is 4, 2, 1,000, 2,
1,224.
2, 2, 4. Okay. Then 5 multiplied by 2 will give us 10x. 5 multiplied by 3 will give us 15y. 15y equal to 5 multiplied by 456. What's that? 2,000.
2280.
2280. So this will cancel this. So 15y minus 4y equal to 2280 minus 1224. All right, here is 11y equal to is that 10224. So
1056.
1056. Therefore, y equal to 1056 divided by 11. Y is equal to what?
96.
96 naira. Okay. Then we substitute. Substitute for y in equation 1. Equation 1 is 5x plus 2y equal to 612. 5x plus 2y. Y is now 96 equal to 612. Therefore, 5x equal to 612 minus 96 multiplied by 2. It give us 192, I think. Yeah. Is it 192?
Yes, 192.
Therefore, 5x equal to 4 what?
420.
420. 420. Therefore, x equal to 420 divided by 5.
84.
X is equal to 84 naira. So I would then say shadow price. Shadow price. Now, at that point, y, let's go back. what are the constraints you have at that point Y? At this point Y, where you have the equation, what are the constraints? You know, we have 4 different constraints in this question. The first one was material kilogram. The second constraint was skilled labor. The third constraint was unskilled labor, and the last one is matching hour. So this at this point, why? What are the constraints that you have there? So let's go back to our graph. You know, this 30, this 48, this 48, and the 39 are the 2 constraints. So that is skilled labor and then unskilled labor, right? The constraints are skilled and then unskilled labor. Okay. What's wrong with you? All right. So I can then say which of them. So I can then say the skilled labor is 84. Put it here first, naira. So the constraint here is the skilled labor, which is 84, then unskilled labor, which is 96. Now, you remember, we said that shadow price is the extra contribution derivable from the additional units of limited scarce resources that have been fully utilized at the optimal level of activity. So the limited scarce resources is skilled and then unskilled labor, okay? Skilled and unskilled labor are the constraints in the question. So this is how to calculate shadow price using the dual method. Finally, you can imagine only one question since. Wow. You still have number E, part of the question. The examiner is asking you to suggest the ways in which the identified model may be used to overcome capacity constraint. Now, what are the capacity constraints? Examiner has told you in the question that material kilogram is limited to 25,000 kilogram. Skilled labor is limited to 48 hours. Unskilled labor is limited to 39 hours. And the matching hour is limited to 50 hours. So examiner is now asking you to identify the model, to identify how the model can be used to overcome capacity constraint during the following month and indicate the type of cost which may be incurred in overcoming each constraint. If you mention the constraint, if you mention how they are going to, if you mention the constraint without talking about how they are going to identify each constraint, you cannot earn your full mark. All right. So to solve this, let me show you. Let's use the golden book so that, yeah. So to answer that number E requirements, to answer the requirement number E, okay. Now, this is requirement number E. The following courses of action can be taken to overcome the capacity constraint. The first one, remember, the first constraint is material X kilogram, which is not sufficient. We are given only 25,000 kilogram of material X. So how do you overcome that constraint? So this is my response. The company can borrow loan to buy additional material X kilogram needed to maximize contribution towards profits. Though this may result in interest expense being incurred on the loan. You know, when you borrow loan, the loan is not for free. All right, the loan is not for free. Therefore, there will be interest that you are going to pay. So even though you have access to loan to buy additional material kilogram needed, then don't forget there will be an additional cost to be incurred, which is the loan, in this case, interest expense in this case. All right? Because examiner has told you to suggest the way in which the identified model may be used to overcome capacity constraint during the following month and indicate the type of cost. So the type of cost when you borrow loan is the interest expense that the company will incur. Then number two, response I provided there, the company can outsource production capacity to a reliable supplier. Okay, the company can outsource production instead of the company to manufacture the component to manufacture grade A and B internally. They can outsource it to a reliable supplier. However, this may increase production costs, lower quality of industrial varnish grade, loss of proprietary technology, and impair the reputation of Oshimiri. You know, I've changed the name. And impair the reputation of Oshimiri, especially if the supplier cannot deliver according to specification. All right. So that's my response to that. Okay. So the kind of cost that may arise if the company outsource production capacity would be loss of reputation, okay? Loss of reputation or loss of proprietary technology. It's not compulsory. You have to indicate all of this. You can just mention one or two of them. You are good to go, all right? Then number three, the skilled labor can work overtime to meet the required labor hours, okay? Skilled labor can work overtime to meet the required labor hour. You know, for skilled labor, we only have 48,000 hours. So how do you overcome that constraint? You need to ask the skilled labor to work overtime. Of course, if the skilled labor work for overtime cost to compensate for the extra hours worked. Okay, so that's that. Then the next one, number four, the company can also hire additional labor to meet the required labor capacity. So if the company hire additional, instead of the existing workers to work overtime, the company can hire additional labor to meet the required labor capacity. Of course, once you hire additional labor, that means you need to pay additional labor costs. Additional labor costs will be incurred. So that's the cost associated with that. Then number five, I also said that the capacity of the machine can be increased to enable shift work. Okay. Now, of course, the work can be done, the workers can be doing a kind of a shift. Okay. They can be doing a kind of a shift in order to ensure that they meet up with the production requirement. Okay. So the capacity of the machine can be increased to enable shift work. This may increase production, this may increase productivity, but may result in additional overtime costs being incurred because when you are do shifting, so that means additional costs will certainly be incurred and may lead to machine breakdown. When you use the machine excessively, all right, it may result to machine breakdown. All right. When the machine is breakdown, then you are going to incur another cost to repair it. All right. Then the last one that I mentioned here is that a new machinery that can produce better and high quality products with increased operating efficiency may be purchased. So in this case, of course, that means even though production volume has increased, but the company will incur a significant amount to purchase the non-current assets. All right. So this, for you to be able to earn your 6 marks in that requirement number E, this is the way you are supposed to answer the requirement. So again, you can summarize it on the day of your exam. There's no need for you to talk too much. But again, if you do it this way, even better than this, good for you. You earn your 6 mark and you pocket it, move to the next one. All right. So this is the end of the question. Let me know if you have any questions so that we can move. Well, I have one more illustration. You can see this is a big one. So in the second illustration, wherever we stop today, we continue in our next class by the grace of God. So let me know if you have any question on this requirement or on this question so that we can move to the next one, please. Okay. All right. In that case, let me switch so that we can move to another question. All right. Let's solve this question that involve shadow price also. That's Akanchawa. Okay. Let's solve this illustration number 2, Akanchawa Limited. Yes, who is helping us? Some of you have disappeared. No worries. Who is helping us to read illustration number 2, Akanchawa Limited, page 46?
We have
Yes.
less than 30 minutes.
Who is helping us to read? Priska, go ahead.
Ah,
You are the one making noise in my class. We are read. Yes, go ahead, Priska.
Akanchawa Limited has the following data relating to its purchases: Toro and Kobo per unit. Fees overhead is budgeted at 275 naira per annum. Related data for each department are employee, number of week, hour per employee, wages rates. In the present environment, it is not possible to engage any more employee. You are required formulate the linear programming equation and show on a graph the mix of products which will maximize the contribution of the company. What is the resulting profit? 2. Determine the shadow price.
All right, thank you, Priska. Yes, that is the question. So, again, in the number 1 requirements, you have to formulate the linear programming model and determine the optimal production plan. Not only that, you should also indicate the resulting profits. So that's a complete package. This question is a complete package. You also have to determine shadow price. Let me stop sharing this and quickly move to the working note. So this should be faster than the first one because you already understand the concepts. So this is solution. So illustration 2, page 46. The name of the company is Akanchawa Limited. All right. So examiner is asking you to formulate. So this is from the beginning. So you are starting from the beginning. So the first step we are going to do is to define the variables. So the examiner has given to you 2 products, Toro and Kobo. You cannot use Toro and Kobo to construct your graph. So you need to define the variables. So I can then say, let Toro equal to, which letter do you want to use Toro for? Can we use A and B or T?
T.
A or, okay, let's use T. All right, then let Kobo equal to K. So with this, we have defined the variables. Step 2 says you should formulate the linear programming model. So I would then say formulation of linear programming model. To do this, there are 3 steps. The first step is to state the objective function. Okay, objective function. I will then go to the question. What objective does Akanchawa wants to achieve? Is this to maximize contribution or to minimize cost? As you can see, examiner has mentioned profit. You have maximization of contribution there. So in that case, I need to go and calculate contribution per unit. How do you get the contribution per unit? In this question, examiner has given you selling price and then variable cost. So let's determine contribution per unit. So I can say contribution per unit for total and cover. Selling price. How much is selling price for total? 200 and 240 for cover. 200, then 240. Then you are going to less variable costs. According to the questions, we are given different variable costs. We have direct material, 45 and 50. Direct material, 45, 50. Then we have direct wages. We have three different departments. Department 1, direct wages for Department 1, according to the question, is 16 and then 20. Here is 16, here is 20. Then Department 2, we have direct wages of 22.5 and then 13.5. 22.5, 13.5. Department 3, we have 10.30. 10, direct wages of 10, then 30. Then we also have variable overhead for total is 6.5 and 11.5. 6.5, 11.5. So with this, I can then get my contribution per unit. So 45 plus 16 plus 22.5 plus 10 plus 6.5, then minus 200. What do you have? Am I on my own?
100.
100. Okay. 70, 25, 55. That's 125. That's 115. Okay. So I've gotten my contribution to be 100 and 115. I would then say maximization of contribution. Maximization of contribution equal. The contribution of T is 100. So 100T, 100T plus 115K. So with this, I've stated the objective function. The next one is to state the relevant constraint. I would then say subject to. There are three different constraints in the question. The constraint is on labor hour for three different departments. That's labor hour constraint in department 1, 2, and 3. Therefore, I will say department 1, department 2, department 3. So we need to go and calculate hour per unit for each product. So in this case, I will then come here. I want to determine labor hour per unit. Labor hour per unit, which is labor cost divided by labor rate. Labor hour equal to labor cost divided by labor rate. So for department 1, for total, okay, I can even use the two. Let me use a table to do this to be faster then. Or let me just do it one by one. So for T, department 1, department 2, department 3 equal under T, Direct wages for T, Department 1 is 16 naira. So I would then say 16 naira divided by, what's the wage rate? According to the question, Department 1, you are told that the wage rate is 2 naira for Department 1, 2 naira. So divided by 2, this will give us 8 hours. We are still on total. Direct wages for Department 2, total is 22.5. Here is 22.5 divided by the wage rate for Department 2, according to the question, is 2.25. Here is divided by 2.25. This should be 10 hours. Please confirm. Kemi, are you still there? Kemi. Please confirm
Yes,
the
we are
number.
here. Yeah, it's
Okay.
correct, sir.
So Department 3 for total is 10 naira for direct wages, 10 naira. Then wage rates for Department 3 is 2.5 divided by 2.50 equal to
That's
4
hours.
hours. Then I will now do for Kobo. Department 1, 2, 3 for Kobo. So direct wages for Department 1 is 20 naira. Okay, 20 divided by 2 will give us 10 hours. Then Department 2 for Kobo, 13.5 divided by 2.25. That should be, what's wrong? 2.25. So this should be what? I think that's 6.
6.
This is 6 hours. Then Department 3 direct wages is 30. So here is 30 divided by 2.50. This should be 12 hours. Okay, so that's, I can then go and indicate it. So the first one, you are going to pair the two. Department 1, 8 versus 10. So 8T plus 10K. Because we are maximizing contribution less than equal to, now we need to go and determine the total capacity. We need to determine total capacity for each department. All right. Maximum capacity or capacity constraint. So how many hours do we have in each department? For Department 1. For Department 1, according to the question, examiner has told you that there are 20 number of employees in Department 1, and each employee requires 40 hours. Therefore, 20 multiplied by 40. 20 multiplied by 40 hours will give us 800 hours. That's the maximum. Department 2, there are 15 employees. Then they require 40 hours. What do we have there? That should be 600.
600, sir.
Okay, 600 hours. Then in Department 3, we have 18 employees. 18 multiplied by 40 hours required. That should be 720 hours. Okay, that's the maximum capacity. Therefore, I can then come here to say less than equal to 800 hours. Then for department 2, hour per unit is 10 for T, then 6 for K, 10, 6. 10 T plus 6K less than equal to 600 hours. Then the last one, department 3, hour per unit is 4 for T, then 12 for K. Okay, 4, 12. 40 plus 12K less than equal to 720 hours. So with this, we have stated the relevant constraint. Finally, step 3 for the formulation is to state the non-negativity constraint, which states that negative output is not permitted. So we have two variables, T and K. Must be the unit we are going to produce for T and K must be greater than or equal to 0. So with this, we have stated the objective, we have formulated the linear programming model. All right. So step 3 of determining the optimal production plan is to bring out the equation and solve using elimination method. So you can just say elimination. All right. So bring out the equation. The first equation is 8T plus 10K. 8T plus 10K equal to 800. The second one is, second equation is 10T plus 6K. 10T plus 6K equal to 600, equation 2. Then 40 plus 12K equal to 720, equation 3. So we now solve using elimination method. So 80 plus 10K equal to 800. Let T equal to 0. Therefore, 10K will then be equal to 800. So K will be equal to 800 divided by 10, which is equal to 80. All right. Then the other parts, let K equal to 0. If K is equal to 0, then 80 will be equal to 800. Therefore, T will be equal to 800 divided by 8, which is equal to 100. I'm done with equation 1. I will then pick equation 2. Equation 2 is 10T plus 6K. 10T plus 6K equal to 600. Let T equal to 0, then 6K will be equal to 600. K will be equal to 600 divided by 6, which is 100. Then let K equal to 0. If K is equal to 0, then 10T will be equal to 600. Therefore, T will be equal to 600 divided by 10 equal to 60. Again, I'm done with the second equation. I'll move to the third equation, which is 40 plus 12K equal to 720, equation 3. So let T equal to 0. So if T is equal to 0, 12K will be equal to 720. Therefore, K will be equal to 720 divided by 12, which is equal to what? That should be 60, I think. Let me confirm.
Yes.
Okay,
60.
60. All right. Then let's K equal to 0. If K is equal to 0, then 40 will be equal to 720. Therefore, T equal to 720 divided by 4. This will give us, what do you have? Is it
18. 18. 18.
180.
180.
180.
180. Okay. So that's that. Now, the next we want to do is to construct a pivot table. All right. We need to construct a pivot table. All right. So that's step 4. This step 4 or step 5? That should be step 4. Step 1, step 2, step 3. Elimination is step 3. Then step 4, we construct a pivot table. Okay. So I have K. Sorry, I have T, then I have K. The first equation is equation 80 plus 10K. 80 plus 10K equal to 800. Okay, so when T is equal to 0, then K is 80. K is 80. And when K is 0, T is 100. All right. The second equation is equation 10T plus 6K. 10T plus 6K equal to 600. Okay. Let me draw this. All right. So in this, when T is equal to 0, in equation 2, when T is equal to 0, K is 100. K is 100. And when K is 0, T is 60. So the third equation is 40 plus 12K equal to 720. So when when T is 0, K is 60. And when K is 0, T is 180. All right. Step 5, we need to construct a graph. Step 5, construct a graph. To construct the graph, you look for the highest figure for each product. Let me do it this way, make it bolder this time around. Okay, let's manage this as it is. Right. So let's say this is T, this is K. So we want to plot T against K. Now, from our pivot table, the highest is 180, the lowest is 60. For K, highest is 100, lowest is 60. So we can do 50-50. So we can say 1, 2, 3, and 4. So here will be 50. Make it border. Here will be 50, 100, 150, then 200. Let me push this one out of this place. This is T. Okay. Then for K also make it 50-50. Here is 50. Let me push it down. Here is 50, 100, 150, then 200. Okay, starting from 0. So for the first equation, I don't need to waste time. Just go ahead. Go and asterisk 100 for T. For T, where can you find 100? Let me change the color. So here is 100. You asterisk it. For B, sorry, for K, K is 80. 80 is before 100. So 80 will be somewhere around this place. Here will be 80. Then you join the two together, 180. Okay? So write out the equation. This is equation. This is equation 80 plus 10K equal to 800. Then the next one, second equation, T is 60, K is 100. 60 should be somewhere here. Okay? Then 100 is here. Join the two together. Okay, write out the equation. This is equation 10T plus 6K equal to 600. And the final equation, T is 180, K is 80, sorry, K is 60. 180 should be somewhere here. All right, here is 180, then K is 60. 60 should be somewhere here. Here is 60. Then join the two. Let me see. Okay, better. Right? Then you write out the equation. Let me change the color so that the arrow will look different. Okay. This is equation. This one is for this. Let me remove the old one so that the point of arrow will be clearer. Okay. So this is equation 40 plus 12K equal to 720. All right. This is, let me remove this. 20 plus 6K equal to 600. Then 80 plus 10K. 80 plus 10K equal to 800. So at this point, you need to find the point of intersection. Based on our diagram, we have 3 points of intersection because we are maximizing contribution. At this point where you have 60, there's 1 point of intersection there. So let's call it A. Let's call it point A. This 60, where you have 60 is the point A. Then T and K intercepted at this point. So let's call that point B. Then T and K intercepted at this 60. Let's call it point C. Okay? So of course, all of these points are the feasible region. These are the feasible region. Okay? Internal. So we need to get value for T and K at point A, B, C. So I can then say at point A, B, C. I want to get value for T and K. Okay. We're almost there. We can't complete the question today. So now for point A, at point A, here is point A where you have 60. So the value of T at point A is 60. Value of B, trace it down, is 0. So at point B, you cannot get the accurate number if you are not using the graph sheet. So you keep that one on hold. Then you move to point C. Point C, where you have 60. When you trace it to the left, T will be equal to 0. Then K is 60. So we need to get value for T and K at point B. All right. Okay. I've exhausted my sheets. Hopefully, it will not scatter my diagram. Let me see. Okay. That's good. Let me add one more, just in case. All right, quickly. So, I would then say to get values for T and K at point B, step 1, identify. Please, on the day of your exam, there is no need for you to be doing all this story. You already know what to do. Just go straight to point B. All right, go straight to point B in your diagram, identify the two equations and solve using simultaneous equation. That's all. For the purpose of this class, that's what I have to bring it down. So identify the equations that intercept at point B. Okay, then step 2, solve the equation simultaneously. All right, so I would then say at point B, what are the two equations? Let's look up. So this is the point B here. At this point, T and K intercepted at point B. So there's one equation. We have this equation of 60 and then 100. This equation of 60 that went to 100. Okay, what equation is that? That's the second equation, this equation here. Then at this point B, there is another equation that went up. This equation that went to 180 and then 60. 180 and 60. Okay, 180 and 60. That's the third equation. Okay, that's the third equation. So The second and the third equation are the one that intercepted at point B. So 10t plus 6k. So 10t plus 6k equal to 600. Then 40 plus 12k equal to 720. Then we now solve using simultaneous equation. So 4 multiplied by 10t plus 6k equal to 600. I want to believe I'm not on my own. Majority of you have disappeared. No worry.
No
No
we are
worries.
with you. We are with you,
Oh,
sir.
thank you. So 10 multiplied by 40 plus 12k equal to 720. So 4 multiplied by 10 will give us 40t. 4 multiplied by 6, 24k. 4 multiplied by 600 will give us 2,400. 10 multiplied by 4 will give us 40t plus 10 multiplied by 12, 120k. 10 multiplied by 720 will give us 7,200. So this will cancel that. Therefore, 120k minus 24k equal to 7,200 minus 2,400. So 120 minus 24 will give us 96k equal to 7,200 minus 24. That should be 4,800.
4,800.
Therefore, K will be equal to 4,800 divided by 96. Therefore, K is equal to what?
50.
50.
50. Okay,
Yes.
so here is 50. I will then say substitute for K in equation 1. So anywhere you see K, you put 50. In equation 1, we have 10t plus 6k. 10t plus 6k equal to 600. Sorry. Anywhere you see k, put 50 equal to 600. Therefore, 10t will be equal to 600 minus 300. 6 multiplied by 50 is 300. Therefore, 10t will be equal to 300. So t equal to 300 divided by 10. T equal to 30. So t is 30. T equal to 30. K equal to 50. All right, so I will then go back. So T is 30. K is 50. So when you look from your graph, if you are using a graph sheet, by the time you trace at this point B, when you trace it to the left, you are going to get 30. When you trace it downward, you are going to get 50 using the graph sheet. So now that you have gotten that, just determine the solution table. That's step 6. Solution table. From the solution table, you state your objective function. Objective function. We have 100 of A plus 115 of B. Okay. Then we have total here. Okay. So at point A, B, then C. Okay. All right. So 100 multiplied by quantity of A at point, is it point, sorry, this is T, 100 of T, 115 of K. So at point A, T is equal to 60, K is 0. T is equal to 60 plus 115 multiplied by 0. So here will be 6,000. Then 100 multiplied by 30 plus 115 multiplied by 50. So carry your calculator, open a bracket. Okay, 100,
8,750.
8,750, 8,750. Then 100 multiplied by 0 plus 115 multiplied by, I think is 60. Yes, 60 multiplied by 60.
6,900.
6,900. So now you need to determine the optimal level of activity. The highest contribution, the highest weekly contribution is 8,750. Therefore, that's the optimal level of activity. This is the highest at point B. At point B. Therefore, I would then say optimal product mix. Optimal product mix optimal production plan. So the company should produce products. The company should produce on 30 units of Toro and then 50 units of Kobo in order to maximize total weekly contribution of 8,750. That's that. You can just put it in words. That's ICAN Chawa Limited should produce 30 units of Toro and 50 units of cover to maximize weekly contribution. To maximize weekly contribution of 8,750. That's all. Finally, examiner says you should determine profit. So step 7, you need to be very careful here. What kind of profits? Is it weekly profit you want to determine or annual profits? When you go back to the question, the information is as per week, but the fixed overhead given to you is of 275,000 naira is per annum. So you cannot use 275,000 per annum with the profit of with the contribution of weekly. So with weekly contribution, so you need to convert one to the other. Say for example, if you want to calculate weekly profits, then I will pick the weekly contribution. I will say weekly contribution, which is 3,750. Then weekly fixed overhead. Fixed overhead, let me shorten it. I need space. Okay. Will be equal to the annual fixed overhead is 275,000. How many weeks do we have in a year? We have 52 weeks. So examiner did not tell you in the question whether you should use 52 or 50 weeks. So where examiner is silent, you are at a liberty to use any one. So you can say you can use 52 weeks. Therefore, divided by 52 weeks. So 275 divided by 52, 275,000 divided by 52. That's 5288, 5,288 naira. So when you find the difference, to give you the weekly profits. All right. So this will then be 3,000, 3,004 something. Let me see. Let me use calculator.
3462.
3462.
62.
So, but if I want to calculate annual profits, if I want to calculate annual profit, for example, annual profits, since my fixed overhead is per annum, so to now get annual profits, I will say annual profits, sorry, annual contribution. Which should be equal to the weekly contribution of 8,750 multiplied by 52 weeks. What do we have?
455,000.
455,000. Then I can then less the annual fixed overhead of 275,000. So this will give us annual profit of 180,000. Is it 180? I think so.
Yes, 180,000.
So this is the annual profit. So you are at liberty to either calculate weekly profits or annual profits. Whichever one you do, examiner will mark for you. But if you do weekly, it's better. All right, so that's that. Let's stop it in our next class. Even though we have about just within the next 5 minutes or 10 minutes, we do the shadow price, but we are going to do that one in our next. What? Shadow price, it can be, okay. Let's see. We can quickly do the shadow price. Doesn't take time. No, it's already late. I know some of you are even struggling, you know. You can imagine only 10 people left. Majority of you have disappeared. No worries. So any question for me? So this is where we are going to call it a day. In our next class, we just solve the shadow price, and that will be the end of linear programming. So I want to encourage you to go and study, go and read our cost volume profit analysis. That's the next topic we are going to do. All right. Joseph is still here. Angela is here. Femi is on. Foluke, Ahmed, then Joy Ime, Oreoluwa, others have disappeared. All right. So thank you guys for waiting behind. I really appreciate. I'm sorry once again for extending the time beyond
Thank you,
the.
sir.
Yes, I will see you next time by the grace of God. Good night, everyone.
Good night, sir. Thank you, sir.
Good night, sir.
Yeah,
Thank you.
good night.